Imagine that tonight, while every living thing is asleep, something impossible happens. No explosion, no flash of light, no sound, not even a warning. Instead, the universe quietly performs a single mathematical operation. Every distance that exists is divided by 2. The Earth is suddenly half as far from the Sun, the Moon is half as far from Earth, and every galaxy moves closer to every other galaxy. Every atom becomes half as wide, every wavelength of light becomes half as long, every mountain, every ocean, every cell in your body, every measurable distance in existence is silently reduced by exactly 1/2. Now, ask yourself a question. Would you notice? Would tomorrow morning feel different? Would gravity suddenly become stronger? Would your heartbeat change? Would your house become smaller? Your first instinct is probably to say yes. Of course, you would notice. How could anyone miss the universe shrinking? But think a little bit more carefully. If your body shrunk by half, then the ruler you use to measure yourself will also shrink by half. The atoms inside your head will shrink, the neurons inside your brain will shrink, the tape measure in your drawer will shrink, the buildings around you will shrink, the earth beneath your feet will shrink, everything will change together. Nothing would remain fixed, and without something fixed for comparison, what would smaller even mean? Perhaps the universe could shrink completely unnoticed. Perhaps size is not an absolute property of reality. Perhaps large and small exist only because we compare one thing to another. That sounds less like arithmetic and more like philosophy. But hidden inside that strange question lies one of the most deepest ideas in mathematics. Because before we can understand division, we first need to understand what a number really is. From the first moment we enter school, numbers are introduced as counters. 1 apple, 2 apples, 3 apples, 4 books, 5 birds. Number seems inseparable from object. Take the object away and the numbers disappear. Or do they? Imagine an empty universe. No star, no planets, no matter, no energy. Now place a single dot somewhere inside that emptiness. How will you describe where it is? You cannot point to it, you cannot name it, you cannot measure it with words alone. Instead, you assign coordinates. 3 numbers, an x coordinate, a y coordinate, and a z coordinate. Suddenly, numbers return, even though there is nothing to count, because numbers have a second identity. They are not only quantities, they are locations. The number 5 can actually mean 5 apples, but it can also mean 5 units away from its origin. -3 can mean depth, or it can mean 3 units away from the opposite direction. Numbers secretly describe geometry. They describe where things exist, and if every object in the universe is ultimately just a collection of coordinates, then changing the coordinate changes reality itself. This is the hidden bridge between arithmetic and geometry. The symbols we write on paper are not merely counting objects, they are describing space. And that realization changes the meaning of division forever. Take a single point on a number line. Place it at 2. Now, multiply it by 2. That point moves to 4. Multiply again, it moves to 8. Again, 16. Again, 32. Well, at first glance, it looks like the number is simply getting bigger. But geometry tells a different story. The point itself hasn't changed. It has no color, no mass, no shape. The only thing that changed is its distance from the origin. Every multiplication stretches that distance. The points move farther and farther away. Now imagine doing this to every point on the number line at the same time. Every interval doubles, every gap widens, and every location drifts outward. The entire number line stretches like a rubber band being pulled from its center. Nothing new is created, nothing disappears. Space itself simply expands. This is the hidden geometry of multiplication. It isn't merely repeated addition, it is transformation, a scale, a stretching of coordinates, And if multiplication stretches the universe, then division should do exactly the opposite. Not because someone defined it that way, but because every transformation has an inverse. And that inverse of stretching is contraction. Now, imagine the same infinite grid. Billions of points extending forever in every direction. Now, perform one operation. Divide every coordinate by 2. Watch carefully. The point doesn't vanish. They don't collide. They don't lose their identity. They simply begin moving toward the origin. Slowly, uniformly, and perfectly. So every square becomes smaller. Every circle contracts. Every triangle shrinks. Yet something remarkable survived. The shape never changed. Their angle never changed. Their proportion never changed. Only their size changes. The geometry remains untouched. Only the scale has changed. This is why maps work. This is why blueprints worked. And this is why photograph can be enlarged without changing its proportion. Division preserves relationship. It changes only distance. It is not cutting reality into pieces. It is changing the coordinate system through which reality is described. And that is a far deeper idea than the one we learned in school. Watch this animation again. Every point moves toward the origin. Why? Why not move toward 1, or 5, or even -3? What makes 0 so special? The answer is hidden inside the meaning of coordinates. A coordinate measures displacement from the origin, and 0 is where no displacement exists. It is the reference point from the entire coordinate system. Take a point 10 units away, divide its coordinate by 2, now it's 5 units away, again 2.5, again 1.5, every operation to remove half of its remaining distance. The point never changes direction, it only loses separation. Now, imagine infinitely many points doing this together. Each follows its own straight path toward the center. The result looks almost gravitational, as though the origin is pulling the entire universe inward. But that isn't gravity. Nothing is attracting anything. The rule is purely mathematical. Every coordinate is being scaled by the same factor. The motion emerges automatically. Perhaps 0 is not merely another number. Perhaps it's just an angle which all scaling transformations are built. Imagine standing beside an ant. To the ant, a blade of grass is enormous. To you, it's tiny. Now, imagine standing beside the earth. You become microscopic. Now, zoom outward. The earth becomes microscopic compared to the sun. Then, the sun becomes microscopic compared to the galaxy. And the galaxy becomes microscopic compared to the observable universe. So, what is truly large? And what is truly small? The answer is surprisingly difficult because size is always relative. There is no cosmic ruler floating through space declaring what 1 meter should be, and nature never labels anything. Only humans do. Meters, centimeters, kilometers. These are agreements, not law of physics. The universe does not know what a meter is. It only knows relationship between objects. It knows ratios, it knows geometry, and that is why changing scales often changes nothing fundamental. The equations remain the same, and the shape remains the same. The relationship remains the same, and perhaps size itself is an illusion. Perhaps only proportion is real. And if that is true, then division is not making the universe smaller. It is changing the language in which the universe is measured. Take a triangle. It could be drawn on the tip of a pencil, or it could be large enough to span an entire continent. Its size changes dramatically, but is it still the same triangle? Look closely. Its angles never changed. The ratio between the sides never changed. The internal structure remains untouched. Only its scale is different. This is one of geometry's deepest ideas. Geometry is surprisingly indifferent from size. It cares about relationship. It cares about symmetry. It cares about proportion. Imagine enlarging a map of the world. The country becomes bigger. The ocean becomes bigger. The city moves apart. Yet, nothing about the map is fundamentally different. The same roads connect to the same places. The same rivers flow through the same valleys. Now imagine shrinking the map until it actually fits on your fingertip. Again, nothing essential has changed. The geometry remembers. And this is why architects can actually draw skyscrapers on papers, and this is why engineers can actually build bridges from blueprint. This is why your phone can actually zoom endlessly into an image. Scale changes, structure remains. Division is one of mathematical operations that actually reveal the hidden truth. It changes magnitude without destroying identity. And perhaps that tells us something profound. Perhaps mathematics has always been care more about relationships than absolute quantities. Now, let us leave line behind and step into a plane. Draw a square. Its side length is 10 units. Its area is 100 square units. Now, divide every coordinate by 2. The side length becomes 5. That feels natural, right? But the area does something unexpected. It doesn't become 50. It becomes 25. Half the length. 1/4 of the area. Why? Because the shrinking happens in 2 independent directions. The width shrank, the height shrank, the contraction happens twice. Now move into 3 dimensions. Imagine a cube, 10 units long, 10 units wide, and 10 units tall. Its volume is 1000 cubic units. Divide every coordinate by 2. Each edge becomes 5. The volume is now 125. Only 1/8 remains. Now, extra dimension multiplies the effect. This is one of the hidden powers of scaling. The higher the dimension, the more dramatic the transformation becomes. Space does not shrink linearly. It collapses accelerates with dimension. The universe becomes far more sensitive to scaling than our intuition expects. Take a circle. Stand far away, it looks perfectly curved. Now, zoom in. The curve becomes gentler. Zoom in again, the curvature almost disappears. Zoom in again, nothing astonishing happens. The curve begins to look like a straight line. Keep zooming, it becomes impossible to tell that it was ever curved at all. This simple observation lies in the art of calculus. Calculus study changes by examining smaller and smaller neighborhoods. It shrinks space, again and again and again, until complicated objects reveal simple behavior. This is why derivative exists. This is why tangent lines works. This is why physicists can describe motion with astonishing precision. Division quietly powers the entire process. Every limit, every differential equations, every gradient, every optimization algorithm, hidden beneath them all is this same idea. Shrink the space enough and complexity begins to disappear. Now, return to the question we asked at the beginning. What if the entire universe were divided by 2? Perhaps the answer is stranger than anyone expected. Perhaps nothing observable would happen at all, because every observer will shrink, every ruler will shrink, every atom will shrink, every wavelength of light will shrink, every measuring device will shrink with the universe itself, and there will be nothing left unchanged to compare against. And without comparison, the idea of smaller loses its meaning. This is why modern physics is filled with ratio rather than absolute measurements. They just seem to care about relationship far more than raw size. The universe does not announce that something is 1 meter long. That label exists only in human language. Reality knows only how things relate to one another. Perhaps that is the deepest lesson hidden inside division. It is not merely the operation of splitting. It is not merely the inverse of multiplication. It is the mathematics of changing scale, the mathematics of transforming geometry, the mathematics of rewriting the coordinate system through which reality is perceived. So, next time you divide a number by 2, don't imagine cutting a pizza into smaller slices. Imagine standing out to the universe itself, watching every galaxy, every star, every planet, every atom, every point in existence move silently inward together. Not because reality is collapsing, but because the ruler used to describe reality has changed. And perhaps the universe was never made up of numbers at all. Perhaps it was always made up of relationships. If you like this, make sure you like and subscribe for more, and I hope to see you next time.